Hello. This video is recorded to provide answers to exercise 5.7 part 2 interview practice in the data analytics course offered by CareerFoundry. The first question, what does the CRISP-DM methodology for data mining entail? What does the data analyst do in each step? CRISP-DM stands for Cross-Industry Process for Data Mining. It's a structured and validated approach to data mining. The process breaks down into 6 steps. The first step, the data analyst gains the understanding of business objectives. The next step involves understanding the data by gathering and exploring the data and checking the quality issues like missing values or inconsistencies. During this step, the data analyst starts to document everything about the project and the data. Step 3 is data preparation, which involves cleaning the data. In step 4, the data analyst selects and designs a test plan for the chosen models to create a prototype model. Once this prototype model is validated and implemented, it becomes a final model. The 5th step involves evaluating the model with a team of subject matter experts who provide feedback and suggest adjustments if necessary. During this step, the data analyst prepares a presentation to support whether the model should be deployed. Once the model passes the examination, the final step is to implement or deploy it into the program. After that, data analyst continues to monitor and document model performance and investigate the output quality. The second question is, explain what needs to be done before you can forecast time series. In other words, what does time series analysis involve? Before forecasting in a time series analysis, there are 3 main key components that should be considered. These components include stationarity, which implies that the mean and variance remain the same over time, even if the data itself changes. Autocorrelation, which shows patterns where data points correlate with themselves at specific time intervals. And seasonality, which involves predictable fluctuations at regular intervals. By examining these factors, we'll help with understanding the data's nature and making accurate forecasts. The third question is discuss the main principles of data ethics, as well as what companies or organizations could do to uphold these principles. The main principles of data ethics, including transparency, privacy, accountability, and security. These help ensure that data is used in ways that respect individuals' rights and promote fairness. To uphold these principles, companies and organizations can implement various measures such as transparent data practice, strong privacy policies, and data security measures, and ongoing education for employees and stakeholders. The fourth question is, imagine you are an analyst at a financial services company and you have some concerns about bias in the way a predictive model was measured. How would you raise your concerns with your manager? Make some suggestions for how to avoid measurement bias in the future. I would communicate my perspective directly to the manager, supported by evidence and information that indicates the presence of bias. And to avoid measurement bias in the future, I would recommend designing and clearly communicating the testing procedure to stakeholders. This should include how we plan to control for bias during data collection, measurements, and analysis. The fifth question is explain the difference between regression and classification models in predictive analysis. When would you use one of these models over the other? A regression model is used for predicting continuous numerical values or quantities, such as predicting stock prices, temperature, or ages. We use regression models when we expect there to be a relationship between input and output variables. On the other hand, a classification model predicts output by assigning input data to predefined categories. For example, a spam filter on an email account, categorizing emails as spam or not spam, or disease diagnosis through determining the positive or negative outcomes. We use classification models when we predict discrete outcomes. Okay, that's all. Thank you.